Hey guys, welcome back to my channel. In this video, we'll be doing the part 2 of exercise 3.2a question number 1. That is, we'll be doing questions 13 to 22. So let's get started. In this question, like we have done already in questions 1 to 12, you just have to go from taking one part of the question which is easily differentiable, and then you have to make that your constant term or something, and then you have to differentiate the whole thing with respect to that, right? You consider one term as t, and then its differential is there in the question, or you form it in the question, take that as dt, integrate it like that, and then eventually substitute the value of t that you had made. So in this case it's going to be a bit complicated. So in question number 13 here, instead of directly differentiating here, you'll have to do a bit of manipulation. Now what manipulation will we have to do? This is not in a form where you already have the differential of 1, and it's dx. I mean, taking dt is not really easy in this case. So what we'll be doing, we'll be making it in a form which is easier for us. So what will we do? We'll multiply and divide by cos square x. So multiply and divide by cos square x. So what will we get? Integral of under root tan x by cos square x upon sin x cos x by cos square x dx. What will this become? The cos square x will become sec square x. So under root tan x sec square x upon, one cos cancels the other, so it becomes sin upon cos, which is tan x dx. Root tan x, so this becomes 1 by 2. So you have integral of sec square x dx upon under root tan x. Let tan x equal to t, dt is equal to sec square x dx. So it becomes integral of t to the power 1 by 2 and dt over here. So t to the power minus 1 by 2 becomes t to the power minus t to the power 1 by 2 over here, because you add upon 1 by 2 plus c. So what do you get? 2 and t to the power 1 by 2, that is tan x, and since it's 1 by 2 it becomes under root plus c. So guys, that's your answer for this question. Moving on to the 14th sub question. 14th. So 14th one here is basically the breaking down of this question. You can also write this as x square plus 1 minus 2x upon x square plus 1 the whole square, integral dx. Correct? So what we'll do is integral of x square plus 1 upon x square plus 1 the whole square dx minus integral of 2x upon x square plus 1 the whole square dx. If you take this, it becomes I1 is equal to integral of dx upon x square plus 1, and I2 is equal to integral of 2x dx upon x square plus 1 the whole square. Now in the first case, we know that this will become tan inverse x. Why? Because integral of 1 upon x square plus 1 or 1 upon 1 plus x square is tan inverse x. You can think of it this way: tan inverse x's differential is 1 upon x square plus 1. So now for I2 here, if you take x square plus 1 as t, dt will be equal to 2x dx. So x square will become 2x, and 1's differential is 0, so it doesn't really matter. So you can write this as integral of t square upon dt. So the integral of t to the power minus 2 is t to the power minus 1 upon minus 1 plus c, which is minus of t is x square plus 1. So x square plus 1 to the power minus 1 plus c, which equals 1 upon x square plus 1 minus 1 upon x square plus 1 plus c. So your final I is equal to I1 minus I2, because there is a minus sign over here. So I1 minus I2 is tan inverse x. Now since there's a minus here, it becomes a plus 1 upon x square plus 1, and be it plus or minus, it doesn't matter because it's integral. After all, the integration constant, it doesn't matter, the constant will make sure to change its value as per the question. Moving on to the next sub question. So guys, here's our 15th sub question. 2 sin x cos x upon 3 cos square x plus 4 sin square x. Now looking at this question, the first thought that anybody will have is, okay, let's convert 2 sin x cos x to sin 2x. Now that will be very difficult, it will just make that complicated. So what we'll do is we'll take the whole denominator as your t. So if we have, let 3 cos square x plus 4 sin square x is equal to t, dt will be 6 cos x, and the differential of cos x is sin x. So 6 cos x sin x, and here you have plus 4 to the 8 sin x, and the differential of sin x is minus cos x. No. So this will be minus cos 6x. Why? Because the differential of cos x is minus sin x, and the 8 sin x cos x will be positive and all, into dx. So that will be equal to 2 sin x cos x dx. That is this whole term. So it becomes integral of dt upon t. Now the integral of dt upon t is just log mod t. So log of mod t plus c, resubstituting our t. So you have log of mod 3 cos square x plus 4 sin square x plus c. Moving on to question number 16. Now in this one, it's everything is in the denominator here. So 1 upon root x plus 1 upon 1 upon root x plus x to the power 3 by 2. We can also just write these terms in fractional powers. So x to the power 1 by 2 plus x to the power 3 by 2, the whole upon dx. Correct? So now if you have x is equal to t square, so let x equal to t square. If x is t square, then x to the power 1 by 2 becomes t, and x to the power 3 by 2 becomes t cube. So moving on, so dt will be equal to, okay, so instead of taking dt in this case, we can take dx, which will make the whole thing easier. So dx will be equal to 2t dt. Now we have dx, so let's just substitute 2t dt instead of dx. So that's 2t dt upon x square will be x to the power 1 by 2 will be t, and x to the power 3 by 2 will be t cube. Now if you integrate this whole thing with respect to dt, you get 2, and then you cut t off, right? Integral. So multiplying and dividing by t, what you get is dt upon 1 plus t square. Now 1 plus t square is tan inverse t, so you have 2 tan inverse t plus c. Now resubstituting what you had instead of t, so by this x equal to t square, you get it that t is equal to under root x. So the answer is 2 tan inverse root x plus c. Moving on to the 17th sub question. So guys, here we have the 17th sub question. Now the sub question is a bit complicated if you look at it at first sight. There is x to the power 9 also. You also have 10 to the power x. But if you look at the denominator here, you have 10 to the power x plus x to the power 10. So we can start by taking this as your t. Let t equal x to the power 10 plus 10 to the power x. Therefore, dt will be, first differentiate this, that will be 10x to the power 9 plus differentiating this. A to the power x is a to the power x log a. So that's going to be 10 to the power x log 10. And voila, we got our numerator. So we can write this as integral of dt upon t, which is equal to log of mod t, which is plus c, which is equal to log. Now resubstituting the value of t, you have log mod of x to the power 10 plus 10 to the power x plus c. Moving on to the 18th sub question. So in the 18th sub question here, you have x to the power n minus 1 upon under root 1 plus 4 x to the power n. Now, unlike the other ones where directly had t, then you found out dt and substituted, in this question you have to take t as something which is not exactly in a numerator and which is not going to make it easy directly, because after that the integration is going to be a bit complicated, but still in the forms that you already know. So what we'll do is let x to the power n equal to t. By this you get dt is equal to n x to the power n minus 1. But you have x to the power n minus 1 dx, there is no n. So what do? This implies that x to the power n minus 1 dx is equal to dt by n. So you have under root 1 plus 4t upon in the denominator, and in the numerator you have dt by n. You can write this as 1 by n integral 1 plus 4 to the power t to the power minus 1 by 2 dt. Now we know how to differentiate ax plus b. It becomes 1 by n because it's in the constant term here. 1 plus 4t to the power minus 1 by 2 plus 1 is 1 by 2. And in the denominator you have 1 by 2. And since t is accompanied by a 4, you will multiply that. So half of 4 is 2. So that becomes a 2 plus c. So what do you have here? You have under root 1 plus 4t upon 2n plus c. Now you have to resubstitute the value of t. So that becomes is equal to under root 1 plus 4x to the power n upon 2n plus c. Moving on to the 19th sub question. So guys, here's the 19th sub question. You have 2x plus 1 under root x plus 2 dx. Now what do you take as d? If you take x plus 2 as d, x plus 2 as t, what you'll get as dt is dx. So let 19th question, let x plus 2 equal to t. So dt will be equal to dx. Now if you substitute all of this, 2x plus 1 is nowhere in the question. What do? You find the value of x. X is equal to t minus 2, right? So instead of x here, let's substitute the value of t. So your integral will be 2 into t minus 2 plus 1. X plus 2 is t, so it becomes under root t, and dx becomes dt, which is equal to integral 2t minus 4 plus 1 the whole into under root t dt, which is equal to under root 2t minus 3 into root t dt. Now you can write this as 2t to the power 3 by 2 minus 3 to the power 3 into t to the power 1 by 2 dt. Now since it's integration, you can break it down, which is equal to 2t to the power 3 by 2 dt minus 3t to the power 1 by 2 dt. So 2 t to the power 3 by 2 dt will become t to the power 5 by 2 upon 5 by 2 minus 3 t to the power 3 by 2 upon 3 by 2 plus c. Taking this up, you have 4 t to the power 5 by 2 by 5. 3 and 3 cancel off. So minus 2 t to the power 3 by 2 plus c. Now we have to resubstitute the value of t that we had, that's x plus 2, which is equal to 4x plus 2 to the power 5 by 2 by 5 minus 2 x plus 2 to the power 3 by 2 plus c. Moving on to question 20, you have x to the power 5 under root a square plus x square dx. Now in this question, what we'll be doing is, we'll take a square plus x square as t. If you take a square plus x square as t, your dt will be 2x dx. So let a square plus x square equal equal t. So your dt will be equal to 2x dx. Now x to the power 5. So to find x, you will do x is equal to t minus a square under root. So now we'll just substitute everything. You have integral t minus a square to the power 5 by 2 into under root t dt. Now here you have dx only, so this becomes dt by 2x, and since x is equal to this upon 2 under root t minus a square, that is t minus a square to the power 1 by 2. So 5 by 2 minus 1 by 2 will make it a 4 by 2. So what we can do here is, we can rewrite this as integral t minus a square to the power 4 by 2, that is 2 root t dt and 1 by 2 outside. Now we can just expand this term, which is equal to 1 by 2 integral of t square plus a to the power 4 minus 2a square t into root t dt, which is equal to half integral. Now you can break this down if you want. So half integral t to the power 5 by 2 dt plus half a to the power 4 integral t to the power 1 by 2 dt minus the 2 comes outside, so there is no half in this term, and a square comes outside as well, a square integral t to the power 3 by 2 dt. Just integrating all of this, 1 by 2 t to the power 7 by 2 by 7 by 2 plus half a to the power 4 t to the power 3 by 2 upon 3 by 2 minus a square t to the power 5 by 2 upon 5 by 2 plus c. 2 and 2 cancel off over here, the 2 goes up in this case. So you have t to the power 7 by 2 upon 7 plus a to the power 4 t to the power 3 by 2 by 3 minus 2a square t to the power 5 by 2 upon 5 plus c. Now instead of t everywhere, we'll be substituting a square plus x square. So a square plus x square to the power 7 by 2 upon 7 plus a to the power 4 a square plus x square to the power 3 by 2 by 3 minus 2a square plus x square to the power 5 by 2 upon 5 plus c. Moving on to the last two questions of this question. So guys, here are the last two sub questions of the question, that is sub questions 21 and 22. Let's do this. So basically in this one again, you don't have the direct values that you can put in. So what you'll do is you'll take one of these as t. Now this one has a complicated value, that is minus 1 by 2. So let's take that as t. So in 21, let 2 minus 3x equal to t. dt will be equal to minus 3 dx. From this you also get that 2 minus t by 3 is equal to x. So now using all this information, let's substitute everything. But if you see here, you don't have a minus 3 dx, you only have a dx. So your dx will be equal to minus dt by 3. Substituting all these values, 5 minus 3x becomes 5 minus 3 into 2 minus t by 3. 2 minus 3x is already t, so it becomes t to the power minus 1 by 2, and dx becomes minus dt by 3. 3 and 3 cancel off over here, so you have integral of 5 minus 2 plus t into t to the power minus 1 by 2, and minus 1 by 3 comes outside as a constant dt over here. So it becomes minus 1 by 3 integral of 3, 5 minus 2 is 3, and t minus t to the power minus 1 by 2 comes here, t to the power minus 1 by 2 plus t, now here t into t to the power minus 1 by 2. Since these powers add up, this becomes t to the power 1 by 2 and the whole thing dt. You can write this as minus 1 by 3 into 3 integral of t to the power minus 1 by 2 dt plus minus of 1 by 3 integral t to the power 1 by 2 dt. Now this becomes 3 and 3 cancel off, minus t to the power minus 1 by 2, t to the power 1 by 2 upon 1 by 2 minus 1 by 3, t to the power 3 by 2 upon 3 by 2 plus c. So it becomes minus 2 root t minus 2 by 9 t to the power 3 by 2 plus c. Resubstituting our value of t, you have 2 under root 2 minus 3x minus 2 by 9 2 minus 3x to the power 3 by 2 plus c. Moving on to the last sub question, that is 22nd sub question. Here you have 7 plus 4x plus 5x square upon 2x plus 3 to the power 3 by 2. Now again, whatever has a complicated power, you will take that as t. So 2x plus 3 has a complicated power. Let 2x plus 3 equal to t, which implies that x will be equal to t minus 3 by 2. dt will be 2 dx, which implies dx is equal to dt by 2. Now everywhere you will be substituting the value. So it becomes integral of, now this is going to be about 3 lines long, because everywhere x in the numerator will be substituted by a fraction. So 7 plus 4 into t minus 3 by 2 plus 5 into x square by 5 into x square. So now x square will be equal to t minus 3 by 2 the whole square. T minus 3 square is t square plus 9 minus 6t whole upon the 2 square is 4, the whole thing upon 2x plus 3 is t to the power 3 by 2, and dx becomes dt by 2. 2 cancels off over here. But since you have a 4 over here, we'll be multiplying the whole term, the whole thing here by 4. So you can have 4 in the numerator here and the denominator here, and you can take 4 outside eventually. Right now 1 by 2 goes out, and you have 7 4s are 28 plus, now since you have to make a 4 here, it becomes an 8. So 8t minus 24 plus 5t square plus 9 5s are 45 minus 5 6 are 30t. the whole upon 4t to the power 3 by 2. You can take the 4 out here as well now. 1 by 8 integral of, now t square comes first, so 5t square. Then you have all the terms having t, so 8t minus 30t, that is minus 22t. 28 minus 24 is 4, and 4 plus 45 is 49. Plus 49 by t to the power 3 by 2. Now we'll integrate this term is equal to, breaking down the whole thing, 1 by 8 into 5 integral. Now t square by 3 by 2, that becomes t to the power 1 by 2 dt, minus 22 integral t upon t to the power 3 by 2, t to the power minus 1 by 2 dt, plus 49 integral of t to the power minus 3 by 2 dt. 1 by 8 comes here, multiplying that 5 into 3 to the power t to the power minus 1, t to the power 1 by 2 will be becoming t to the power 3 by 2 upon 3 by 2, minus 22, t to the power minus 1 by 2 will become t to the power 1 by 2 upon 1 by 2, plus 49 into t to the power minus 3 by 2 becomes t to the power minus 1 by 2 upon minus 1 by 2. Adding a plus c over here because it's integration, so the constant. So this is where we had reached in the last step. 1 by 8 over here. So let's simplify the things inside the bracket. 1 by 8 into 2 goes up, so you have 10 t to the power 3 by 2 by 3, minus 2 goes up here again, so you have 44 t to the power 1 by 2, minus 2 goes up again, so 49 2s are 8 comes here, 1 up, so 98 t to the power minus 1 by 2 plus c. We'll be multiplying this 8 everywhere, so if you just cut these off, that becomes 5 t to the power 3 by 2 upon 12 minus 11 t to the power 1 by 2 upon 2 minus 98 by 8, that would be 4, no, that's going to be 49 by 4 t to the power minus 1 by 2 plus c by 8 will still be c because it's a constant. So constant by a constant will still be represented by a constant. So it's easier if you write it as c instead of c by 8. Now we have to resubstitute what we had taken as t into our question over here. So resubstituting that, you have 5 2x plus 3 to the power 3 by 2 by 12 minus 11 into 2x plus 3 to the power 1 by 2 upon 2 minus 49 by 4 into 2x plus 3 to the power minus 1 by 2 plus c. So guys, that's it for the video. Don't forget to like, share and subscribe, and comment down below if you have any queries or suggestions. Now this topic is a bit difficult if you haven't practiced it well, or if you're doing it for the first time. It's a bit complicated, but once you practice sums with this concept, with this topic, you'll get very familiar to it and very comfortable. So if there is any doubt, even a hint of confusion, just comment down below, and thanks for watching.